Okay, here we are, Stats Mechanics Year 1, Chapter 11, Mixed Exercise, Question 7. Been a while since I've done some of these. Alright, so a particle moves along a positive x at time equals 0. The particle passes the origin with a velocity of 6 meters a second. So at t equals 0, the velocity is equal to 6 meters a second. Right. The acceleration a of the particle at time t is given by a equals 2t cubed minus 8. So minus 8? No, minus 8t. Okay. The velocity, find the velocity of the particle at t seconds. So velocity is equal to the integral of the acceleration by time. Okay, and so it is equal to the integral of 2t cubed minus 8t. Okay, so integrating that one, then okay, increase the powers, so that equals t to the power 4. Which one is it? Is it divided by 4? No, it's divided by 4. So 2 over 4 minus 8t squared over 2 plus c, which gives us the velocity equal to, that's a half t to the power 4 minus 4t squared plus c. Now, because of the information at t equals 0, velocity equals 6, we can substitute 0 into both of these, making them both 0 terms, and so 6 would equal c. So the complete part of it, as you put in for b equals 6 when t equals 0, we get 6 equals a half 0 to the 4 minus 4 0 squared plus c. 6 equals c, giving us a final answer of velocity equals a half t over 4 minus 4t squared plus 6. Right, next bit. The displacement of the particle from the origin at time t seconds. Okay, so displacement again, s is equal to the integral of v dt. All right, so exactly the same again. We're just going to integrate it again. Okay, and so s is equal to the integral of a half t over 4 minus 4t squared plus 6 dt. And so s is equal to a half t to the 5 over 5 minus 4t cubed over 3 plus 6t over 1. Okay, and so s plus c. So s is equal to a tenth t to the 5 minus 4 over 3t cubed plus 6t. Now again, we know at t equals 0, s equals 0, so it just cancels out this plus c, making it a 0, because this term becomes 0, this one, so it's just 0, so we can get rid of the plus c at the moment to give us that. Finally, part C, the values of t at which the particle is instantaneously at rest. So that would suggest that when it is instantaneously at rest, that would be for the velocity is 0. We're not talking about the acceleration, we're not talking about distance, so we're talking about solving for this to be equal to 0, this velocity. Okay, so a half t to the 4 minus 4t plus 6. So velocity is equal to a half t to the 4, what was it, 4t squared minus 4t squared plus 6, I think that was it. And so we want to set that to equal to 0. Okay, and now look at taking it out. So we could have t to the 4, 8. We could look at saying divide it all by a half. So 0 equals t to the 4 minus t 8t squared plus 12, just to make the numbers a bit more whole. We could then say, well, we could go for a trick and say, well, if t squared equals, I don't know, let's go for a letter x, for want of a better letter, then we can say 0 equals x squared minus 8x plus 12. We can use a polynomial solver on that, and hopefully it's going to give us some roots in there. So let's just quickly put that into the calculator. Where are we at? Equation polynomial, second degree. Right then, 1 on that, minus 8 here, and plus 12. Okay, and we get a x is equal to 6 and an x is equal to 2. And so we get the fact that t squared is equal to 6 and t squared is equal to 2. So t is equal to plus or minus the square root of 6 and t is equal to the square root plus or minus of 2. T is greater than 0, they told us in the question, so we can ignore the minuses and say t is equal to the positive square root of 6, and t is equal to the positive square root of 2. Ignore the minuses. Okay. That's mechanics. We should give it as some decimals, I guess. Okay, so what's square root of 6? 2.44. 449, and the square root of 2 is 1.414. All right.